All right, today we are diving into a truly monumental engineering project. We're talking about a titan of the seas that completely rewrites the rulebook. And to give you a sense of the scale, let me just ask you a question.
Sounds like a crazy riddle, right? But believe it or not, this thing is real. We're talking about one of the world's largest and most advanced container ships ever built. A true behemoth, and it's powered by a complete revolution in fuel technology. So, you gotta ask, why on earth would you build something this massive? Well, this story isn't just about being big. It's about a fundamental change in how global trade works. And it all starts with one simple, staggering fact. Yep, you heard that right, 90%. Just think about that for a second. Almost everything you own, your phone, your clothes, the food in your kitchen, it probably spent a good amount of time on a ship. There are nearly 40,000 cargo ships out there on our oceans at any given time. The scale is just, it's hard to even wrap your head around. You see, for decades, the game was simple, just build bigger. But we kind of hit a wall. Ships got so big, they couldn't fit through crucial waterways like the Suez or Panama Canals anymore. So this French company, CMA, CGM, they posed a totally new challenge. What if the race wasn't about size anymore? What if it was about sustainability? And this chart, wow, it just lays it all out there. This shows you exactly what a huge leap they were aiming for. Instead of that thick, heavy fuel oil, they bet everything on liquefied natural gas, or LNG. And the numbers here really do speak for themselves. I mean, a 99% drop in sulfur dioxide, 91% less air pollution, and on top of that, slashing CO2 by 20%. This is an absolute game changer. So the mission was set. But how do you actually go about building not just one, but 9 of these giants in only 2 years? Well, the answer is a shipyard the size of a city, with literally thousands of people working around the clock. You don't build a ship this big all at once. You do it in these giant pieces, they call them blocks. First, you've got more than 12,000 sheets of steel getting sliced up by a laser that's 3 times hotter than the surface of the sun. Then those sheets are welded into these enormous multi-story blocks, and they're already fitted out with all the wiring and pipes. Finally, these city-sized Legos get welded together. Now, to really put that welding into perspective, we're talking about 1,250 kilometers of it on just one ship. If you stretch that out, it would go all the way from Karachi to Lahore. That's just a mind-boggling amount of work. But here's the crazy part. For all that massive scale, the work demands almost microscopic accuracy. I mean, you're lifting a 790-ton block into the air with these giant cranes, and if you're off by a single millimeter, you could compromise the whole structure. All that hard work, months of it, just gone. Okay, so the whole is together. Now let's zoom in on what is quite possibly the most complex, most difficult components of the entire ship, the massive fuel tank designed to hold that super-cooled LNG. So what is this stuff? LNG. Well, you take natural gas and you chill it way, way down to a crazy minus 161 degrees Celsius. It becomes a liquid, and that lets you store 600 times more of it in the same space. But, you know, trying to keep something that cold on a moving ship, that presents some pretty epic challenges. This was a huge engineering puzzle. First, the tank had to be like a perfect thermos, keeping 20 million liters of fuel at that insane temperature for a whole trip from Asia to Europe with no refueling stops. Second, it had to handle the immense pressure from any gas that boiled off. And third, and this is the big one, it had to be completely 100% airtight. Any leak would be absolutely catastrophic. So with all this high-tech engineering, how do you make sure it's airtight? You'd think it's some complex laser system, right? Nope, they used something brilliantly simple, almost old-fashioned. Workers would just paint a soap solution over the welds, put a glass container over it, and create a vacuum. If a single bubble appeared, you had a leak. Simple and totally effective. But the final piece of this giant thermos is pure space-age stuff. It's a super thin 1.2 millimeter wavy steel membrane. This is the same kind of tech they use on space stations, and that wavy design is the genius part. It lets the metal shrink and expand with those extreme temperature swings without cracking. Okay, so the ship has its incredible fuel tank. But what good is fuel without an engine powerful enough to move 70,000 tons of steel across the ocean? Let's take a look at the heart of this beast. And I mean, this isn't just an engine, it's practically a building. It weighs 2,000 tons. It stands 6 stories tall. The maintenance crews can literally walk around inside of it. And that massive structure cranks out an incredible 85,000 horsepower. That power comes from 12 enormous pistons, each one a full meter wide, all firing in perfect harmony.
And all of that power is there for one reason: to turn this, a single 90-ton propeller. It's 10 meters tall, about as high as a 3-story building, and it was cast in one single perfect piece. But again, it comes back to that amazing contrast between sheer power and delicate precision. How do you connect that monster of an engine to this giant propeller perfectly? The alignment has to be flawless. So engineers use this clever old-school trick. They coat the shaft in a thin layer of blue dye, fit it into the propeller, and then pull it out. The dye shows them exactly where the parts are touching, letting them make adjustments down to the micrometer.
So, the hull, the fuel tank, the engine, all the big pieces are in place. This floating city is almost ready. But before it can rule the seas, it has to go through final assembly and a whole series of absolutely punishing tests. The final numbers are just as staggering as the build itself. It takes 1 million liters of special paint just to protect the hull from the ocean. It's the combined effort of over 10,000 workers, all collaborating for a year and a half, and that's just to build the very first of these 9 ships. And finally, it's the moment of truth. 15 days of intense sea trials. They pushed this thing to its absolute limits. We're talking engine speed tests, emergency braking, checking its advanced Smart Eyes system that gives the crew a 360-degree view. They even test the anchor drop. And get this, every single link in that anchor chain weighs 300 kilograms. It has to pass every single test perfectly to get certified. And that really brings us to the heart of it all. This isn't just about bending steel or building giant machines. It's a testament to human ingenuity, to collaboration, and to the relentless, tireless work of thousands of people, engineers, welders, designers, who turned an impossible idea into a reality. In the end, the shipyard won its race against time, delivering all 9 of these revolutionary ships. They're out there on the world's oceans right now, sailing more cleanly and more efficiently than ever before. It just proves that we can move mountains of steel across the sea, which leaves us with a final thought. What seemingly impossible challenge are we going to conquer next?